A new work plan file is entered once the creation of the geometry is completed. The unmachined part has a diameter of 30 millimeters and a length of 82 millimeters. In other words, there is a 1 millimeter allowance at each end. Also, the clamping situation will be correspondingly adapted. For technical production reasons, the threaded end has to be machined first. Otherwise, it would not be possible to change the clamping position. First of all, a face roughing work step is created with the 80-degree cutting tip. Knowing that only part of the red surface has to be faced, the area will be limited. In other words, only the red face now visible will be machined. Facing is carried out with this cutting data, which originates from the tool database. The 2D simulation clearly shows facing in all detail. Now the same tool is to be used to perform rough cutting in the longitudinal direction, based on this cutting data. The 3D simulation will be activated. In order to obtain a consistent chip cross-section during finishing, the undercut is rough cut using the 35-degree cutting tip. The red surface has to be limited to this undercut accordingly. The residual surface is automatically detected by the software. In the following work step, the right-hand contour is finished. Now details of the finishing path have to be defined. The setting of any desired approach vector is possible. The finishing path has to end at the end of the 0.5 radius. This is the cutting data for the finishing step. The 3D simulation shows the process as it would be on an actual machine. Thread cutting on the right-hand side completes the operating steps. The threading path is defined by means of a pictograph. Numerous data are identical and can be used. The rotational speed is converted into a value that is easier to read by the program. The magnifying glass is also useful here. The corresponding rough cutting steps and one smoothing step are carried out. The result produced is shown on the right-hand side. Now it is necessary to change the clamping position. This work step is adopted without simulation. First of all, the production has to be identical with that on a CNC lathe, with one longitudinal rough cutting cycle. In other words, a tool is selected that is capable of machining all materials. In this case, the 35-degree cutting tip is used. Here you can follow production in real time. The plus key can be used to set higher speeds. The process can be slowed down by pressing the minus key. This is the typical chip removal process in a cycle. Production would take 48 seconds. Now we want to optimize the process. To do so, the work step will be filed. Instead, the 80-degree cutting tip is used first because it permits higher cutting data due to its better stability. Here you see an accelerated clip of the production process with the 80-degree cutting tip. At this point, the software intelligence permits the retrieval of the work step from the file. The software automatically finds the residual quantities. This process makes it possible to significantly shorten the production time. Is further optimization possible? Yes, it is. Rough cutting is performed with the round cutting tip having a 3 mm cutting radius. Watch the production process. Roughing with the 35-degree cutting tip can be deleted, as this time is even shorter than the previous strategy. A total time reduction of more than 30% was obtained by software intelligence and production competence. The final facing step is done with the 35-degree cutting tip. The optimum presentation of the production process and of the machining compartment imply a high degree of security prior to the first chip being removed in practice. We want to have another look at the work plan before the NC program will be created. Here the work steps are graphically presented together with the individual times. As shown at the top right, the production time amounts to 1 minute and 32 seconds. The work plan being okay the way it is, it will be filed in the demo folder under the name Handhold. the last step in the generation of the NC program. A large number of post-processors for almost all control systems used in this industry are integrated in CNCplus. We now select the post-processor for the Haas controls. The NC program is saved under the number 123. The NC program for the selected control system is generated by one single key actuation.